Hello, everyone. Welcome to another live stream. Got an interesting one this week. We're talking about the recent changes to the personal licenses, how that affects you, and this is a tech talk. So we're not going to start debating how and why, but we really want to show you. I think in NC code, so I want to sort of show you what the NC code is going to look like that you're running on the machine. So that's hopefully what I'm going to try and get out today. How are we looking, Spence? Are we actually live, or am I just talking into space?
We are indeed live. It feels like we haven't been live together for a long time.
No, it
So,
hasn't.
welcome back, Rich.
Yeah. Well, more welcome back to you because I've done the one with Matt and Dylan. So you're the one that's abandoned us all.
I did. Holidays and various other commitments, but I'm super happy to be back. Super happy.
Have we got Eyal on yet?
No, Rial. Well, let us know. Are you there, Rial?
Ice cream.
Ice cream can't make it today live. He's going to watch the
Ouch.
replay after work. We've got Cash.
Okay.
Cash.
Yep.
And Patrick Holt.
Oh,
Hi,
very
Patrick.
nice.
Thanks for joining.
Perfect. No, it's looking good. So again, yep. We will be talking through a lot of the actual changes. Oh yeah, and of course, if this is your first live stream, my name's Richard Stubley. I'm a process specialist out of the Birmingham Tech Centre over here in the sunny UK for once. And Spencer works with me. He's a process specialist as well, and he's up in the north of England.
I am in the rainy north. Oh, it's sunny north. The sun's just come out for the live stream. What a coincidence.
There you go. No, brilliant. So yeah, everyone as always, we like to hear where you're from, what you've been up to, what have you been making in Fusion this week, and also let us know if there's any problems with the audio or video because we have minimal feedback on our side on the audio. Well, minimal as in none. So please let us know if there's any problems and we'll adjust it in real time for you.
Absolutely. Let us know in the chat any audio, any video issues, and let us know what you've been doing since our last live stream. What you've been making, what you've been designing, where are you based is always a good one. So let's hear where you are in the world, and over to you, Rich, for the live stream, I guess.
Perfect. Yeah. Last thing, everyone. We love these things to be as interactive as possible. Post your questions in the chat, and Spencer will interrupt me and make sure your voice is heard. So I was trying to think, what could I do as a little project to show everyone? And what I've chosen here is, again, for those of you that don't know me, I like building cars. And the most recent car that I've built has got a horrible plastic key. So what I've actually done is I have made a nice little key fob for it. So two halves that join together. Let me get these screws out and show you. Here we go. Two halves join together like so and make a nice key fob. So I had to make a fixture for it, fixture plate to hold it down. Let's just turn off the other bits and pieces, that one and that one, hold it down, bolt through there. And my aim was I wanted to make all of this with my personal license. So we've got a personal license that our team used for a bit of testing and a bit of proving out. So I wanted to prove that I can still be just as productive with a personal license. Yes, there are some hoops I have to jump through, but we're going to hopefully show you what those are now. The first thing I'm going to cover is tool changes. This has been a huge cause of confusion out there. People thinking we've disabled their tool changes. We haven't as such. What we have done is disabled posting out multiple toolpaths. So what I've got here, have a look at my side 1 op10. Let's quickly just flick the old visibility back. I mean, I absolutely love that. If you don't know what I'm doing here, I've got synchronize visibility with active setup. So if I choose a different setup, it puts the right components on for you. Little tip if you haven't played that before. Anyway, I digress. So I've got a facing toolpath using T2. I've got an adaptive path using T2. I've got a load of stuff using T10. And then 2 toolpaths with T5. So before I would have right clicked, I'd have gone create NC program, use my global post, and I would have hit post. And I now get the warning telling me that I cannot post process operations that contain tool changes. So what that actually means is I can output everything to do with T2. So let's do that. Let's click on those two, right click, create NC programs. Some of you might be familiar with the way of post-processing. I always create NC programs. I much prefer the view of it. And also I get this little operations tab here that show me exactly what's getting output. And I can, add and remove options from there. So for me, this is, this was added after post-processing NC programs was, and it's better in my opinion. People are going to shout and lynch at me there, but that's what it is. So anyway, I've got 2 toolpaths here. I'm going to now hit post, hit yes, and look, I've got NC code. So that's really, really key here, everyone, is that I have still had that post-processed. So I've still got it all post-processed. I've still got my tool call in here. I've got my facing toolpath. I scroll down and I've got my adaptive as well there. So you can see I have still managed to post-process multiple toolpaths in one NC code. So please don't get confused by people out here saying that you've completely removed my ability for tool changer. We really haven't. We've just stopped the fact that you can't cascade lots of tools together. So let's have a quick look at that. We even still output the M6. So your automatic tool changer, if you have got one, will still work. You didn't see it just because I had the option ticked off to not output the M6 because my little Denford November hasn't got a tool changer. But if you have got a tool changer, it will still work. So what I would do, I'd process 1001 for that. I would then select all my T10s, right click, create NC program, call that 1002. I should probably give this a proper name as well. Tool 10 progs. Let's hit post, yes. I mean, if I was good, I'd actually call these some things as well. Side 1 up 10. Oh, up 110, I'm not going to correct that. And then I'll do the final tools there, and let's go post-process, which is a different way of doing it. So that's what we've got there. You can see there that you've got different ways of outputting the same ways of doing things to get the tool going. Have you got any questions on that, Spence?
No questions yet. There was some confusion with the audio at the start, but that seems to have rectified itself. So nothing in the chat yet. So let's hear what you have to think. Any questions for Rich? Keep them coming in. I think one thing that makes posting this with the same tool quite easy, I guess, is the option in the preferences to turn on that tool number within the browser. So you can see exactly which tool is being used for which operation.
I see what you mean. Yeah. You to actually see that option on there. Yeah, no, that is good on there. But yeah, please everyone, we really want this to be like a Q&A type lecture type session. So if you've got any questions on that, I'm trying to do the content quite quickly today, so we've got lots of time to answer questions. So that was just showing that you can still output, roughing, finishing, facing toolpaths, as long as they've got the same tool. Everything's going to work there. That's absolutely fine. So hopefully that's helped some people out on there. Right, okay, we can circle back around to this later, but we'll go on to the next big change that's happened on there, and that is all around rapids. So what do we mean by we've disabled rapids? What we've effectively done inside of Fusion is we've got different types of rapid moves. We have got the ones you can see. So let's jump back into Fusion. So if you look here at this 2D chamfer operation, the yellow moves are rapid moves. For those of you who didn't know, you can right click on a tool and go show log, not show log. You can go view toolpath. And then you actually see the moves here are rapid. These are then plunges, I'll then come back out, and then rapid again. So hopefully there's some people out there that are going, wow, didn't realise I could do that. So you can even step through the whole toolpath, look at what's going on. And this is also really nice because it shows you the coordinates that get output as well. But you can see here that there are rapid moves throughout this part. So those are the rapid moves that we know about. We know those rapid moves because we're outputting them in NC code. But there are potentially up to 2 other rapid moves that we have no idea about. And that is how we get to this entry point. And then what happens at the exit. So let's say I start off at home. The move from home to there Fusion has no clue about that. It doesn't know where you're starting, and the same at the end of it. It doesn't know where you're going home either. So we've got rapid moves we know about and rapid moves we don't know about. And what's happening here is we are changing the G0s into G1s, and the G1 value will be the value of the cutting feed rate. So what does that actually mean in terms of time for you all? So I've hopefully made a little comparison here of what this means in time for you all. So you can see there, I've picked 4 hobby machines and 4 commercial machines. So everyone knows I've got a Denford Nova Mill, so that's why I choose that one. We've got the workspace CNC, because I know someone on the call's making it. I can't remember the name, really sorry. And then we've got Carbide 3D, because again, they're very common machines for Fusion users. We've then got some more commercial machines. So those of you that don't know, a Haas GM2 is a gantry mill, so like a massive router, effectively. You can look, the longest travel there is 2 meters I've got on that. DMG 60 Evo, the ones of you that watched our live stream last week or the week before, can't remember, that was the machine that Dylan was using. So again, very high production commercial machine. The DMU monoblock is the big one in our workshop. It's got a huge 1.25 meter table. And then the Haas VF2 YSS is the little machine where I normally live. Hopefully you guys out there know what a Haas VF2 might look like. So what I've tried to do here is plot the longest travel of the machine. So we can see we've got my Denford Nova Mill has got 255, right up to the Haas GM2 that's got 2.2 meters. And then the rapid time. So my Denford Nova Mill can travel at 750 millimeters a minute, right up to the quickest one being the Haas GM2, which is 53 meters a minute. That is chuffing quick by anyone's scale. What I've done then is plot the time it takes to rapid across the whole of the machine's travel. So it takes my Denford Nova Mill 18 seconds to go fully left to fully right. Whereas it takes the DMG 60 Evo less than a second, and I can vouch it is that quick. Dylan, who runs that machine, never puts it at full speed because it's scary the speed it runs at. So that's how quickly the machine can go across its full length of travel at its rapid feed rate. The next thing, again, these aren't exactly the most accurate figures, but I've just tried to put down some common feed rates for those machines. So for me and my Denford, when I'm cutting aluminium or aluminum for any of you out there, I tend to use 450 millimeters a minute. We asked Winston Moy actually from Carbide 3D what he would sort of use as a normal feed rate. He said around about the 2 meters a minute mark. The Haas GM2 is probably a bit quicker than that because it's got a higher horsepower spindle, probably about 3 meters a minute, although it's cutting the same sort of material. And then the 3 machines at the bottom, the production CNC, proper workshop machines. Again, I've had to put in a rough estimate of about 1 meter a minute because they'll be cutting anything from aluminium to titanium to steel. So I had to just choose somewhere around about the mark. But what I wanted to show now is the next column, time to feed. So the time it takes to feed across the longest travel. So rather than doing a G0 move, a rapid move, we're now going to do that G1 move. So you can see my Denford Nova Mill has gone from 18 seconds to 30 seconds, an increase of 12 seconds. The workspace CNC has increased by 4.5. The Carbide 3D is either 8 seconds or 3.5 seconds. So you see, it's not a great deal of additional time really added to your cycles because the hobbyist machines, the rapid speeds aren't that quick on them to begin with. But then we look at the production machines, the commercial users that shouldn't be on the hobbyist licenses really. We look at that Haas GM2, it's going to add 50 seconds to their cycle time. You look at the DMU monoblock, it's going to add nearly 1.5 minutes. So hopefully you can all sort of see what we've tried to do here. We looked at ways we could try and stop commercial users abusing the hobbyist license, or the personal license I should say, while still making sure that we can offer you a really good package to still make sure you can make things like key fobs when you want to in your garage at home. So hopefully, that's shedding a bit of light on the whole rapid scenario. Let's have a quick look at the NC code and see what the NC code looks like. Any questions, Spence?
There isn't actually. We've
got
asked.
anyone
I know. Well, we've asked what machines everyone's working with. We've got Dave, who's built his own 800 by 600 by 150 router, running Mach 3.
Out of interest, Dave, what is your rapid feed rate, if you wouldn't mind me saying? Just have a quick look at this comparison.
Yeah, absolutely. And then we've got Yiji Wu, who's got a Datron.
Oh, they're very quick machines. They are very quick machines.
So keep the live chat coming, and I think that the table that you're showing, that you showed before, you can see the physical split, can't you, between the increase in time between a more of a commercial user type machine versus more of a personal user type machine.
Yeah, definitely. There is literally like a hard split between those top 4 and bottom 4. So hopefully that's going to look right. Let's jump back into Fusion, everyone, and let's have a look at the actual NC code. So let's output just this chamfering pass here. So again, right click, create NC program. I'm just going to call it number 5 on there. There we go. If I can click in the right place. So I've output 1005. So again, what I can see here is the very first thing I'm going to look at doing is moving up and down there. So hopefully what we can see, we're still outputting the tool and we are still outputting the correct moves for what we need to do. So the NC code hasn't actually changed. It is still working as it should. You're not going to suddenly start not having moves. It's just going to not work exactly as quick as it did before. So that's what we have got on that NC code on there. So again, hope this is all making sense. One thing that I've just reminded myself of, which I didn't say before, is where I outputted both of these tools. So again, let's just do that once more. Select the 2 tools, right click, create NC program. Let's hit post. Yes. And it posts those out absolutely fine. So it posts those 2 codes out absolutely fine. And it does the facing toolpath and then it does the adaptive toolpath. This is actually something that someone said on the forum, is they couldn't get this to work. They couldn't output 2 of the same tool. Right, I'm in this setup now. Let me make another facing pass. So I'm going to click on here, face. And I'm going to select my tools. So I want to use T2, the 8mm end mill. So if I click on that 8mm end mill there, it's going to use the 8mm end mill. But if I choose the 8mm end mill from my library, so what I've got here, the HASS BTC is my library of tools that I've got on our machine. And then this is our document library as such. If I choose the tool out of the HASS library, so out of the main library, it is actually now giving it a different individual ID in the background. So if I just hit OK there, and I try and post out these 2, I'm going to create an NC program and hit post. I'm getting a warning here saying that it can't do it because it's a different tool. Now, you and me know that it's effectively the same tool, but Fusion thinks it is a different tool. So a little bit of advice there. If you're selecting the same tool multiple times, select it from the document library you've got, not the main directory here. So again, little thing, if you do that, it will hopefully mean you don't keep getting those warnings come up, and you can still post multiple toolpaths using the same tool over and over again. So yeah.
Brilliant, Rich. We've got a quick question for you.
Go for it.
So Jim's not quite understanding the post issue. He's saying what he did before was he had 4 tools over, let's say, 6 operations. What we did before is he was, of course, post all out at once and change the tool manually. He wants to know, what does he do now?
Okay, brilliant. So what you'd have done before is you'd have chosen all your toolpaths here. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 toolpaths there using 3 tools. So tool 2, tool 10 and tool 5. if I right click, create NC program, you can see my operations that I've got all those selected. We are now stopping you from doing that because our thought behind this is that, this is a very much, if you've got an automatic tool changer and you're posting all of this stuff, you really shouldn't be on a personal license. So if I hit post now and hit yes, you get this warning come up saying you can't do this with your personal license. But what you can do very easily is just split this into the tools you've got. So let's get rid of all these NC programs, or else this is going to start to get very cluttered. So I'm going to make an NC program now for these two tools. So I'm going to create an NC program. Let's just call that tool change 1 and call that 1001 and hit post. So I've now got the NC code now for my first two toolpaths and my first tool. I've now got 4 toolpaths here using tool 10. So this will be my second tool change. So I'm going to create NC program, call that 1002 and call that tool change 2. Let's hit post. Yes, and then view NC code. So I've now got the next sort of chunk of code to make my part, and then I'm going to double click those, create NC program, call that 1003 and tool change 3. So what we've now got is we've got 3 individual chunks or files of NC code. These all contain tool 2, these all contain tool 10, these all contain tool 5. So in each one of these NC code files, only tool 5 appears. In this one, only tool 10 appears. In this one, only tool 2 appears. So that is how yourselves out there as hobbyists with personal licenses can still use Fusion to completely make parts with multiple tools. You just have to break down that NC code like we've just shown into those different tools and output that. Hopefully that explains. If it hasn't, say again, and I'll try my best to try and explain that a bit better.
I think that was a really good explanation, Rich. I think for those out there that don't use NC programs, of course, you just can select the operations that use the same tool and just right click and press post. So post NC programs doesn't really matter. The restriction is that it's 1 per tool.
Yeah, very good space. Yeah, so it's nothing to do with the fact I'm using NC programs, but I tend to use NC programs because I really like being able to see what's being output at the time of posting. Because of course, if I've misselected something, I don't know that when I go to post process the old method. I shouldn't really say new way because they're both current, but the NC programs way, you get a really nice view of what's going on. So that's
probably also, sorry, Rich. It's probably also worth pointing out that operation order is still important. So if you have a series of operations and the first toolpath and the last toolpath use the same tool, it could be quite dangerous to combine them into a single NC code because, of course, then they're going to run one after the other. And if you have operations in between that are necessary, maybe to get you down to a new Z level or something, then you also need to take that into account.
Yeah, very good point. Yeah, you can't just, regardless, output everything. So, so if I went here and I've done all this work to machine that, I can't suddenly put my T2 at the bottom machining something where T10 had to machine it out first.
Exactly. Yeah, thanks to WNT16 for pointing that out in the chat.
No, that's really good. Thanks, everyone. Again, please make this as interactive as possible. The last thing people want is just to hear me ramble on for a while with Spencer interrupting.
One more question for you, Rich, before you carry on. Dave would like to know, so he's given me a little scenario, right? So he's got a sheet. He wants to drill a hole in each corner of this sheet, 600 by 800 millimeters.
Okay.
And he's got a 400 millimeters a minute peaking feed rate. Do these changes mean that I'm now restricted at a rapid of 400 millimeters a minute?
So when you say peaking feed rate, if that's what we mean by cutting feed rate, then yes, that is the answer. It takes that cutting feed rate, and what were G0s before will be G1s at that feed rate there.
And the cutting feed rate's specified in the toolpath itself, right?
Or, well, yeah, so it defaults to what was in the tool library, but then you can override it in the toolpath itself.
I hope that makes sense, Dave. Let us know if it doesn't.
And again, we go back. I mean, I'm not denying this is going to slow things down. It's physically impossible for this not to slow things down. But please think back to this table. Like, look at the impacts it's having. The more personal machines that we can afford aren't impacted anywhere near as much as people who are using commercial grade machines on a personal license of Fusion.
We've got some clarity on the peaking feed rate. He meant pecking.
Pecking feed rate.
It's doing hole drilling.
Okay. So the pecking feed rate. Let's. I'm not sure if that is the feed rate for the drilling. Let's just create a drilling op. And so the pecking feed rate will be the plunge feed rate. I imagine, or the feed per revolution. So yeah, it will be taking that. If that is your feed rate for the cutting proportion of the move, it will be taking that. So let's go on to here.
Oh, Rich, your toolpath dialog is slightly off the screen to the right hand side.
How's that?
Sure, that'll be much better.
Yeah.
There's a delay on my side, so
yeah, no, that's fine.
I'll let you know if it's still sticking.
That's looking all good. That's looking all good. Okay, so on here now we've got. I'm looking for pecking. Here we go. Chip breaking, partial tract. Yeah, so it will be taking the feed rate from the cutting proportions of that move. That's what it will be taking on there. So again, hope this is clear to people. We're trying to just take the time today to really go through what we need to show how these changes are going to affect you in the NC code. Cool.
Brilliant. Any more questions? Keep them coming in on the chat. And I'm loving these hard questions. I like hard questions because it trips Rich up a little bit more. So
thanks,
keep the hard ones coming in.
Yeah, again, I don't know the answer to everything. And if I don't know, I will definitely find out for you all. So please ask the questions. I'd much rather we just get them asked and answered. If not, if I can't answer them now, I'll answer them in the comments. But I don't want to see questions going on for months and months on the forums. This is why me and Spence did this live stream. We just wanted to get it out there. It's changes that we're making. We want to make sure that everyone is fully aware. I won't ever run NC code that I'm not happy with, and I'm sure a lot of people out there are the same. So this was to try and show what the actual NC code is going to look like on that. Right, next item on my list is tool orientation. So something that I saw on one of the forum posts again, or it was on the blog post, one or the other, was, well, how do I make a part now that needs two sides machining to it? We haven't stopped you making multiple setups. You look here, I've got side 1 up 10, side 1 up 20, side 2 up 10, side 2 up 20, even fixture plates up 10 and up 20. So I've got 6 setups here, all in one document. So you can see I've got my little fixture here, holding my part that way up. So I machine all these features. I then put 3 M5 bolts through the part that you can see there, hold it down and let me machine the top. So all that I do is define the orientation in my setup. So again, let's talk about something else here. Something a lot of people ask me is, how do I reference between up 10 and up 20? So what I've done here, again, in up 10, I've got these 3 bolt holes that are going to be bolting that component down. Now, there doesn't need to be a massive tie-up for me between up 10 and up 20, because all I'm doing in up 10 is just roughing it out and putting the holes in, and then in up 20 I'm doing the finishing ops. If you look at my adaptive here, if I edit this, I've got 0.2 stock to leave, so I can have about 0.2 of float in my up 10 to up 20 setups, and it won't really make a difference. So I look in my up 20 here now, I flip my part up. These are my 3 bolt holes that will be bolting through into the component, And then this hole in the middle is actually a datuming hole. So this is a hole that I drill in the fixture that I can datum off. So then when I put my component on, which is that one, when I put my component on, it's referenced in that position. And we look at my setup here. Let's turn that back off again. You see my setup is referenced to that hole. So you can still make setups to have the part in one way and another way. What we've stopped though is multi-axis. So the ability on a 5-axis machine to be able to move the tool and go in at a different angle, or move the table and go in at a different angle. If you are lucky and do have additional axes and you have a personal license, what you can do though is set up different offsets. So let's say you had an A-axis that was going to rotate a part, and you wanted to drill a hole on that side, rotate it, drill a hole, rotate it, drill a hole. What you could do is set up G54 with it this way up, G55 on your machine with it that way up, G56 and then G57. So you could set up 4 different offsets and then make 4 different setups for those features. What you haven't got anymore is the ability in the geometry tab to be able to just select a tool orientation and actually in a CNC manner move the tool or move the table with the part into what we call a tilted working plane. Again, decisions that I said I wouldn't get into the why, but I am. Decisions we tried to make on thinking, what is a fair level of use for people on personal, unpaid for licenses versus the commercial licenses. How are we going, Spence? Any more pressing, trying questions to trip me up on?
No, not really. Just people saying thanks.
That's nice to hear that this has been useful.
Yeah, so we got one from Dave. Dave's just pointing out the differences and the time differences between the speeds there and the feed rates. So, yeah, nothing really on the chat. But if you have any questions for Rich, come on, let's hear it. Does your machine have more than 3 axes? Let's hear it in the chat.
Yeah, definitely. So again, just to recap what we've gone over the ability to have different tools and how we output them. So we make sure we select the same tool and we create an NC program or post process there. Make sure that when you select the tool over and over again, you select it from the document library, not from the tool library, because that gives it a different unique ID and it won't work then. So that's something you need to bear in mind. We've looked at the whole rapid situation and how much will that really affect you. I'd forgotten to show you this really cool feature. So you look at this contour operation here, and I'm going to right click and go machining time. So this normally is, I think, 30,000. So this is saying it's going to take 26 seconds. So, when I'm in the garage and I look at the machining time, I think, is that enough time for me to run inside, grab a cup of tea and a biscuit and get back before it's finished? I do use the machining time quite a lot. What you can do is just drop that down to your new time there. So it's going to take an extra, what was it before? I completely forgot. 26 seconds. It's going to take an extra 8 seconds. So on that toolpath there, it's going to take an extra 8 seconds to machine that part with that toolpath. So again, 8 seconds, I hopefully have still got enough time to run inside the house, grab myself a cup of tea and a biscuit, and then come back before that's finished, ready to put the next toolpath on. So again, if you didn't know where that was, it's right click on the toolpath, it is machining time, and you can drop that now down. I mean, to be honest, we can take the tool change time off actually. There we go. So if I take the tool change time off, it drops down even more because it's assuming I have to do a tool change in there. So you can really tailor this to how long it takes you. If your tool changes are manual, it could take you 60 seconds to do a tool change. And then you can have a look and work out how long it's going to take you to do the whole part. So hopefully that's something useful for people out there as well. Or if you like me, to be honest, I have a 6mm end mill in my Denford Nova mill that I reckon I use for 99% of everything I do. I do a bit of wood carving on it with things, make the odd bit of aluminium. It tends to be stuff for my car. I face stuff off quite a lot and make things nice and flat and parallel, and do things like that. And I use that 6mm mill for 99% of what I do. So for me, I'd leave the tool change time at 0, because I don't really change the tools that often.
Your dialogue's off the screen, Rich, I think.
Oh, you should have interrupted me a lot sooner than that.
I just noticed it.
Sorry, everyone.
Just in the chat.
So what we've got here, rapid feed rate. So this is the problem now. I've got a wide monitor, and I have to crop it down in OBS so the resolution's right. So this was 30,000 before, and then we're dropping that down to 450 millimeters a minute. So that's what we've got. And then again, tool change, you can drop that down to 0. So yeah, hopefully this is all proving good tips and tricks for people on how to do things. Anyone got any more questions? Come on, please try and, I don't want to say trip us up, but ask us some questions. What's really on your mind? What do you want to know? And we'll do our best to answer them.
No more questions so far, but yeah, keep them coming in. I think a lovely comment that's just come in is, I guess, if time is an issue for us hobbyists, we should maybe consider subscribing.
That is very, very nice. Again, I'm really going to try and not get into the why behind this. But, you know, it doesn't take a genius to work out that we unfortunately we need paid subscribers to keep the software running. As much as me and Spencer do love the job, we need to get paid at the end of the month, the same as everyone else does. You know, but we really do value the network and the community we've got around it, and that's why we're so committed into still providing an amazing piece of software that you can still use. Again, I've made this key fob with my personal license. Yes, I used the Haas machine to do it because I didn't have enough time to get it running on my Nova mill. But I still use my personal license to make this, and that's really what we're trying to show here, is that we haven't just made changes that are going to completely inhibit any productivity. But what we're trying to do is stop the people that were abusing the system and, you know, outputting commercial grade NC programs. What I mean with that, you could output 30 tools changing, you know, over a 5-hour period, you know, rapid in it left, right and centre. And what we've tried to do is look at what is the general hobbyist and personal license using it for, and make sure they're not as affected. You know, we could have gone in and been very dramatic, but we have really tried. There's been a lot of internal debates, should we say, some angry conversations and some upset people internally about the changes we needed to implement. But what we're effectively trying to do here is secure a future for the software so we can keep providing it.
Yeah, absolutely. And I think the changes aren't supposed to hurt the true hobbyists out there, right? The software is still free. You can still manufacture. You can still 3D print. You can still design.
Yeah.
The changes are designed to hurt, sadly, the people that were abusing the system a little bit. So that's the angle, I guess.
Yeah. And again, we know this is no one really wanted this. We certainly didn't want this, but it got to a point where it needed to be done. So we really appreciate. You know, I was looking at a lot of the comments on the blogs and the forum posts and everything, and I was quite shocked about the amount of support. Like, we've just had people saying, well, if this isn't good enough, then you might need to pay for it. So we really do thank the people out there that are taking the time to properly digest this and, you know, have a look at the reality of the impacts. And that's what, you know, again, I'm going to nip back to that rapid screen, and, you know, I think this does a really nice job of trying to show, you know, those 4 hobbyist machines, personal machines at the top, they're not affected that badly. It's the people with those commercial grade machines that should be under commercial licenses that will feel this effect. But yeah, brilliant. If you want to know more about the why this happened, I know we've just glossed upon it, please watch in the description down below the not live stream but video that Lars Christensen and Steve Hooper did. There are a couple of comments saying that Steve Hooper looked a little bit odd on the video. For those of you that don't know, he had just had a very serious mountain biking accident. You can't tell, but his arm's in a sling at that point. He's in a lot of pain. So there were a couple of comments saying something didn't look right. I can vouch he he was in a lot of pain while recording that. So credit to him for still making sure that he had a decent video with Lars explaining the why behind these changes. So please give that a watch. I know even internally I watch far too many of Lars's videos when I get stuck on something, so I can only imagine how many out there have heard of Lars and actually worked through most of his tutorials.
Absolutely. If you have any more questions that haven't been addressed, hit us up in the comments below, and we will endeavour to answer all the comments that you have.
Yeah, I try and watch it for about 2 weeks, so please get them in quick. Unfortunately, I can't watch them forever and a day, so I try and watch them for about 2 weeks, so get them in quick.
Absolutely. And if you haven't already, give us a like. YouTube likes it. And if you haven't already, maybe consider subscribing. And if you do subscribe, hit that little bell icon and you'll be notified of every new video we make and produce, live streams, tutorials, quick tips. And so, yeah, hit us a subscribe, hit us a like, click the bell icon and you'll never miss another video.
Yeah, brilliant everyone. Really thank you very much for watching us today. Thank you very much for everything you give back on the community pages, on the Facebook, on the Instagram. My wife would testify I spend far too much time looking at our social media while I should be spending time with her. So again, keep keeping me busy and we'll hopefully keep these live streams up. So everyone, thanks very much. Really appreciate it all and see you all soon.
Thanks everyone. Thanks Rich.